remember to log in your YouTube account so that you can leave your question in the comments and we can answer that during the live time. Okay, so today we have like lots of things we want to talk about Gateway API. So let's get started.
Yep. So yeah, while you get everything sorted, Shinchu, hi. Just in case you haven't seen me before, my name is Nick Young.
Yeah.
I work at VMware. I'm the tech lead for Contour and a maintainer on the Gateway API and Envoy Gateway. So I've been doing this stuff for quite a while, specifically. So yeah, I can talk a lot about it. I've made Shinchi promise that she's going to pull me up if I ramble too much. Because I have a lot that I could say about this stuff. So, but I want to keep it so that you're learning interesting things. Please hit us with comments and stuff like that. There's definitely a lot that, like, I've been working on this for like 3-4 years now, so I know I have a lot of background. And so yeah, if you have any questions about it, almost certainly I can probably give you a reasonable answer. So please hit us with the questions.
That's really kind of unique. Okay. Let me share your screen here.
Okay. So this diagram is the one that we were using the last time I was on here when we were talking about ingress. So this is how Contour works to do ingress. So basically, usually when you install Contour, and this pattern goes for many other ingress controllers, you install the Contour controller, and we have a separate data plane. Other people combine these two into one thing. That data plane, usually you come with a load balancer service that creates an external load balancer for you when you're running in a public cloud. And then you use your ingress resources in the API server. Contour reads those, creates config in Envoy for you, and exposes the service that your ingress refers to. So this is how ingress sort of works. It's important to remember this stuff because Gateway API is essentially the bits that we're going to talk about today. Gateway API is essentially like Gateway API actually started as being Ingress v2, but what we found was once we started working on that, we realized that there was a lot of other stuff that we needed to include in there, and that's why the scope expanded out and the name changed. So before I head on, I can't see, is there no questions there? Shinji, is there anything else that you think I should talk about there before we move on?
I think everything is good so far. And I just like send an advertise in the Slack channel to tell people that hey, we are having this show, so everyone who has time can join us.
Cool, awesome. Okay, so let's start this discussion by saying, okay, so the Gateway API is a new upstream API. Let me pull up this is the Gateway API website, gateway-api.sigs.k8s.io. This is the introduction page. I'll walk through this in a minute. But yeah, I wanted to make sure that you all knew about this one. When it comes down to the key part about this is that when we built this, we're sort of reacting to ways that people had used Ingress and found that Ingress sort of missed things or was hard to use. And so the important part of this whole page is this bit here. So we're aiming to evolve Kubernetes service networking through expressive, extensible, and role-oriented interfaces. We've chosen those words extremely carefully. So they need to be, the things that we're trying to build here need to be expressive. They need to express all the stuff that you need in order to do all the stuff you want to do with your ingress traffic through fields in the spec, not through annotations like you needed to do on ingress. They need to be extensible in that you need to be able to add things in a way that you don't need to, again, you don't need to use annotations. Basically, a large part of this is we want to avoid having lots of annotations. And role-oriented is about what this diagram that you can see on the screen is about. As those of us who are doing ingress stuff spent more time doing it, what we found was that it was pretty common that different people who were using the cluster had different reasons why they needed ingress and different things they wanted out of ingress. So so when we started designing the Gateway API, we settled on some personas. So the one that's probably most familiar is application developer, right? This is the person the developer who owns an app, and they want to be able to own some config that they keep with their app that tells magic stuff in the cluster how to make sure that their app is visible on the internet. And so that's one of the sort of key personas, right? Like, that's at the end of the day, that's what this whole thing is about, right? Like, it's actually about making it so that people can run their apps inside a Kubernetes cluster and get and have them be visible on the internet so other people can actually use them. If you don't have that, why even run apps, right? So, but then what we found was that there's also a couple of other groups of people. There's the people who own the cluster. That's the people who own who own each cluster and who administer the cluster. They're responsible for actually installing ingress controllers, managing them, and upgrading them, and doing all of that sort of stuff. Sometimes it's the same person as the application developer, right? If you're running a kind cluster or you're running a small cluster, you're probably the one person doing everything. But in bigger clusters, this distinction between the application developer and the person who actually owns the cluster infrastructure is really, really, really important. And then the last persona we've got is this infrastructure provider one. Sorry, I'll make this a bit bigger. This infrastructure provider one. And so this is basically so actually I've kind of messed this up a little bit. The cluster operator is the person who owns like the individual config of the gateway. They're the one who, say, in a really big organization, say you have like, www.company.com, and that's your company's website. And your company's website, you want to break it up into like different teams. This is one of the things that we built Contour's HTTP proxy to do. You want to be able to break up that config and have multiple teams access that same website or expose things on that same website. You probably don't want those individual teams to have access to really important stuff like the TLS key pairs for that domain name, right? Those are probably going to be, those are secret. You need to keep those properly secret. And so this cluster operator is the person who controls that level of stuff, the gateway. The infrastructure provider is the person who actually installs the controllers. Sorry, it's been a little while since I gave this talk. I messed that up. But so the cluster operator is the person who owns the actual sort of the bits that fit into the load balancer or and the TLS certs and stuff like that. And then the infrastructure provider is the one who's responsible for making sure that the ingress controller is installed. Is that more clear?
So the infrastructure provider is responsible for like having everything you need to run the Gateway API in the cluster.
Yes.
And the cluster operator is responsible for like maintain some kind of like secret or like security settings of the whole cluster that you don't want the application developers know. And the application developers kind of like control how they want to route different traffic to their service.
Exactly. Yeah. So I think the cluster operator is the way I would put it is it's not just the secret stuff. It's also they sort of control so lots of application developers might want to expose their apps, and the cluster operator is the person who makes sure that everybody can do what they want without breaking someone else. So if you have an app and I have an app and we both try to expose it on the same path, the cluster operator is the one whose responsibility is to make sure that the least worst thing happens in that case.
So in this case, the application developer will only focus on their like business logic and how they want to expose their service, and they don't need to worry about like and the cluster operator actually take care of everything else.
Yeah, exactly. So typically, when you do have actually like a large enough cluster and a large enough company that you need this sort of split, the cluster operator is usually like an SRE team or something like that who are sort of making sure that they're the ones who are responsible for making sure everything keeps running and doesn't break and all that sort of stuff. And the infrastructure provider are usually your sysadmin team or the people who are actually configuring and setting up the clusters and stuff like that. It doesn't have to be, but that's a very common way that this breakdown happens. Now this is really important because we've broken up the config that you used to be able to put on Ingress into 3 parts so that each one of those parts is accessible to a one of those personas.
Yeah,
Okay.
that makes sense. And it looks like the storage class, PV and PVC, something like
yes,
that.
it's actually very similar, and we took a lot of design cues from the way that that the storage has design has fallen out. So yeah, so the key resource of the Gateway API is the gateway. That's this one. That's why it's called the Gateway API, is because this is the key resource. Now, gateway classes are like storage classes. They're a bucket to hold multiple gateways. They describe a class of gateways that have a shared config. Now, that shared config may be that it's all implemented by the same controller, or it could be sometimes it's possible to have a controller that has that will reconcile multiple gateway classes, and each gateway class will have like a slightly different config. So you might have one controller that handles like visible to the internet traffic and company internal traffic, or something like that. But like in both of those cases, there's a separate gateway class that makes it clear to people that gateways that belong in that gateway class have some sort of set of different properties.
So
I have to be a bit vague because like we've specifically left this part pretty flexible. Sorry.
Yeah, actually, I have a question here. So, is there? I know that in a gateway class we can configure that which which controller we want to use to like handle this request, handle the gateway of this. Handle this gateway resources, but is there like anything else that we can configure in this gateway class other than the controller name?
Yes. So there is. Let me find the. No, this is wrong. Hang on. I've got to make my window a little bit bigger. So we get there it is. So in the reference section, so the gateway class, the basic spec here has a controller name, which basically sets which controller is going to be reconciling that. But then you can also have a parameters reference. Now, this parameters reference is a standard Kubernetes group version kind and name reference to some CRD that the controller, the person who owns the controller, controls. So for Contour, we've got like a Contour config thing that you can put into the parameters ref that controls how Contour manages the gateway class. And so that's the way that you can sort of configure extra things on there, is basically you can have a parameters ref that points out to some other resource. So the way that we've done it this way so that every controller can have their own config and it doesn't have to be the same, and we don't have to try and generalize people's config across lots and lots of different implementations. It's up to the controller how they do it using CRDs.
Yeah, that's a really flexible way to like configure the controller based on your need.
Yeah.
And so we have like a question from Amin. So hey, there will be any convention tool planned for ingress to Gateway API?
Yes, so I definitely want there to be. I certainly would like to see some built. I built some conversion tools in the past. They're actually a pretty good sort of first project for if you don't understand. Like, it's a really good way to make sure you understand to build a conversion tool. I think that I'd like to sort of see us provide a framework for like a tool that has like a plugin system that means it can read ingress, or it can read HTTP proxy, or it can read your some other type of ingress CID and turn it into Gateway API. That's sort of, in my mind, the ideal end state here. So I guess the correct answer is, will there be one? I certainly would like to see it. Has anyone committed to doing it yet? No. So if anyone out there really wants to learn all the detailed ins and outs of the Gateway API, this would be a fantastic first project for somebody. Everybody's going to need this. I think there's a pretty strong need for it, and I think that it would be pretty likely that something like this would get pulled into upstream very quickly if someone built it. So, if you're out there watching and you want to get involved in the Gateway API, but you haven't had much experience, this is a great way to learn. So,
okay, thanks. I mean, but and hello, Ricardo, one of our old friends of Venture Life. Okay.
Okay, so I think we've talked about GatewayClass. Let's go back to let's go back to talking about gateway, right? So so you have a gateway class that's basically, and you have a controller to reconcile it. Now, how do you actually get some config? And the way you do that is with the gateway. So the gateway defines like a few things. The gateway class name first. So you have to have, this is not optional. You need to have a gateway class name defined in your gateway. And then you need to have listeners and addresses. So listeners is like host names, ports, protocol, like do you terminate TLS? Are there any TLS settings? All that sort of stuff. And then addresses are what addresses has the gateway requested. Now, again, we're talking about spec here, and the Gateway API preserves the usual thing that Kubernetes resources have, is that spec is the request. It is what you're asking for, and then status is what you got, right? And so a behavior that I don't know if we did a good enough job of making clear is that if you don't request any specific address, it's up to the controller what address you get. But in the status, you'll be able to see whatever address your gateway is reachable on in the status, the same way as you can with ingress. So if we, you normally when you create an ingress, there is I think it's like status load balancer addresses is the set of keys that have like the IP addresses you can get to the ingress on. We have a similar construct in gateway so that you can see the addresses in the status. So yeah, as you can see here, there's addresses, and it tells you the listeners, the status of the listeners, and then the status of and then it has general conditions about the gateway. If you haven't seen this conditions pattern before, you should have. It's in pods, it's in nodes, it's in lots of things. This is like the new sort of standard way of telling you what is happening with your Kubernetes resources. And so we've leaned hard into using this standard. Now, before I go on, Shinji, is there any questions from you or anyone else?
I think we're good.
Okay, so let's I'll dive a little bit into listeners. This is the API specification. This is the reference. So let's go. I'm using the V1 beta 1 versions. We have literally just released these. For now, for gateway class, and HTTPRoute are all available in beta. The spec is almost identical for the beta and the V1 Alpha 2 versions. At some point we will retire the V1 Alpha 2 versions of these resources, but we're going to give everyone a little while to get around to it. So in the gateway spec, you can see that you've got a gateway class name. That's just a standard Kubernetes object name. You've got the listeners and you've got the addresses. Now you can see here there's a lot of text talking about this. This is because there's a few things that are a bit tricky about listeners. I wouldn't worry about this for sort of simple use cases. The key parts for a listener are that you can optionally have a host name. The non-optional parts are the port and the protocol. Now, the port number is, the usual TCP port number that you would have for things. So you might have a listener with port 80 that you expect to listen on HTTP and that has a protocol of HTTP, and have a listener on port 443 that has a protocol of HTTPS. You could also have TLS or other types of secure communication on the thing. If you have TLS and you want to terminate it at your gateway, so you want the TLS handshake to actually stop at the gateway and then the rest of it to be in clear text or to be re-encrypted, then you need to have this TLS standard defined that defines the TLS config for the listener. So usually what you would do here is if you want to expose example.com, you have a host name that says example.com and a gateway TLS config that has the TLS details, that has a secret reference that will have the details of the certificate for you. So maybe I don't. Let me just give me a sec, and I might just see if I can pull up some example ones, because I think it might be handy for everybody to be able to see actual things. I just got to get my VS Code window ready. Let's see. So let's do the basic. Here's some basic examples. Just close those. Let me just. Oh, I had a lot of windows open in my VS Code window. Sorry. There we go. Okay, so I will close. I can close that. Okay. And let's. Oh. And I want the view to be a bit bigger. Control. Let me just change my sharing. Okay. I think that should be big enough.
Yeah.
Does that look okay?
Yeah,
Yep.
we can see that clearly.
Okay, great. So this is one of the examples from the Gateway API repo. This is just a very basic HTTP setup. So we've got a gateway class here that's handled by the Acme gateway controller. There's a parameters ref there. Then there is a gateway that has a single listener. That's called HTTP, has the HTTP protocol, port 80. And then we have the other reference that you need, a HTTPRoute. And so this route, if we go, I don't want to flip back and forwards all the time. If you remember in the diagram, HTTPRoute's attached to a gateway, and then the gateway is part of the gateway class. And so the way that a HTTPRoute attaches to a gateway is via this parent ref stanza. So what this part means is that this should attach to my gateway, which is in the same namespace. Okay, and because it doesn't specify anything else, it'll attach to all the listeners. Now this HTTP route is saying, hey, I want to only listen on foo.com, and then I want to send foo.com/bar to my service 1, and then I want to match the magic header with a value of foo and the query parameter great with a value of example and the path prefix of /some/thing, and send that stuff to my dash service 2. So this is a lot of different conditions. You can already see that, and it even specifies the HTTP method as well. So this is all of the possible matches that you could actually have in one rule. Probably most of the time you're not going to use this many matches, right? But yeah, you can see compared to Ingress, where the matching was much more basic, you can match on a lot of different things. You can match on the path. You can match on query parameters. So if you're posting a form or something, you can say, hey, if this form field has this value, then route to a different service. And you can do it via headers as well. Notably, this lets you do stuff like, say, is there a cookie set, or is there an auth set or something like that? And then you can match on the method. So you can say, hey, if it's a GET request, send it here. If it's a POST request, send it here.
Yeah, that's very clear that it's much more flexible than the Ingress object. But actually, if we go back to the Gateway API, to the Gateway resources, so is there any effect if I apply resources like this? So it has a listener, but what does it do?
It has a listener, but without some HTTP routes, it doesn't do anything. Yeah. So it depends on the implementation. Some implementations, when you create the gateway, that is a signal for the implementation to actually go and create like the actual data path. So in Contour's case, Contour works by having Contour is sort of the control plane, and then Envoy is the data plane. And so if you are using Contour with the Gateway API, when you sort of install Contour, you create a gateway class. Contour doesn't do anything. When you create a gateway, Contour says, aha, you've created a gateway. I'm going to go and create an Envoy daemon set, and that daemon set is then ready to serve the config that you add using HTTPRoute. So Contour will go off, and for you, it will create envoys. It will expose them via a service type load balancer. It'll hook up everything you need it to hook up, and then once that's done, then you're ready to start attaching HTTP routes to it. But that's a implementation specific thing. Some implementations will work like that, and other ones won't. It's again, I'm being a bit vague, but that's because the API is designed so that there's not sort of one way to do things. There's the config describes how you want things to look up at the end of the day, but implementations are free to interpret that config in different ways.
Okay, Thanks, Nick. And there's another question from the audience. Is that can you tell me a little bit more about Envoy Gateway and how it relates to the Gateway API?
Sure. I guess we might as well do that now. So Envoy Gateway is a new project under the Envoy Proxy organization. So it's part of Envoy. It is intended to be the sort of the canonical Envoy implementation of the Gateway API. So Contour currently implements the Gateway API using Envoy. Envoy Gateway is intended to sort of make it so that there's an Envoy sponsored, branded, designed, built, and owned equivalent to Contour that supports the Gateway API and only the Gateway API. And so the idea here is that Envoy Gateway is sort of intended to, there's initially in the project there's the Contour team, the ambassador team, and some folks from TCPRoute and some folks from Fidelity. I think one of the big US financial institutions is also involved. I'm sorry to those folks. I can't remember the name off the top of my head. But yeah, so the thing there is that the idea is to make it so that Contour and Ambassador and hopefully eventually folks like Istio or Solo or other people as well are all sort of coming together to build one Gateway API implementation using Envoy, so that we don't all end up repeating the same work over and over again for Envoy. Again, that's only for Envoy. I think that there's definitely heaps of other implementations. If you don't mind, Cindy, I'll just quickly flip back to my. Where's my window?
Yeah, sure.
Yeah, that's not the right window. Where's my window? Let's stop sharing. Which one was it? It was this one. Okay. So yeah, if we go back to the top of this and we go to the overview, there's an implementations page. You can see here that there's a whole bunch of implementations. We've got Contour here. We've got Emissary Ingress. We've got Glue. We've got GKE provides their own implementation. HA Proxy has started working on things. Console, HashiCorp's Console, Istio, Kong, Kuma, Nginx, Apache. So there's a lot of people working on different implementations of this API. That's one of the reasons why I'm a little vague when I talk about it, is that different people have been doing things in slightly different ways. But in terms of Envoy Gateway, it's definitely intended that Contour, that Emissary Ingress, and hopefully in the future some other folks as well who are using Envoy for this reverse proxy use case as opposed to the service mesh use case are all coming together to work to build something. I hope that hit Ricardo's question. Good question though. So yeah, so where did we get up to? We got up to talking about
sorry for interrupt for this, but
no, that's really
we were talking about the gateway.
Yeah. Okay. So I'll flip back to the other screen. This one. Okay. So this is the basic HTTP example. To show you a basic TLS example, this is a gateway with basic TLS. So you can see here that on the list we got two listeners here. We've got a HTTPS listener that listens to foo.example.com, and so it has a cert for foo.example.com, and then you have a HTTPS listener that listens to bar.example.com and has a cert for that. Notably, these both share a port. That's 100% okay as long as other details are different, like the host name. If you're going to share a port, you need a different host name. Another way to do this is to have a single listener with a port of 443 node and like a wildcard TLS, and then say hostname star.example.com, and then your HTTP routes can have foo and bar.example.com in them, and everything will work. And as long as the HTTP route hostnames match the hostname that's in the listener, everything is fine. There's a lot of work went into defining all the spec and everything so that works, but that is definitely how it works. I think actually, oh look, there's actually look at that. There's an example here of what a wildcard one looks like. But
will there be like so does it like do a regular expression on the host name?
No, so this host name that has startedexample.com, this is a DNS label wildcard. So this stands for like, it's not exactly a regular expression. It's like a glob in a file name. It just stands for a label, one or more DNS labels.
Okay.
I just want to look at some of the other things. So some other stuff that you can do is we've got like HTTP filter. So you can modify headers on your request using the request header modifier filter. This says for all requests that come into my.filter.com, they should go to my.filter.service, but before they go, you should add a header that sets my header to the value foo. So there's also remove and set, I think. So add is always add, remove is always remove, and then I think there's set is like just make sure this header is set.
So the HTTP routes not only like define which kind of traffic goes to which service, it can also modify the traffic packet.
Yes, so that's what filters are for. So right now we've only got a couple for like header modifiers and some other stuff, and you can do path rewrite as well. I'm not sure if we've got an example of that here, but yeah. So that's one of the things that you can do. It's pretty like slightly more advanced features. So some of the other things you can do are. So if we look at this one, we've got, this is like the general sort of HTTP routing one, where you've got a gateway here with a HTTP listener, and then we've got a example.com host name. And then here we've also got separate HTTP routes that have foo.example.com/login and bar.example.com. These all connect to that example.gateway, that example gateway that was in this one. So basically here you've got 3 different HTTP routes all being exposed by the same gateway. And this is, again, one of the reasons that we built this, is that in the old ingress world, if you wanted to do this, everybody would have their own ingress objects. And if there happened to be a collision on a host name or something like that, what happened was actually undefined by the spec. Ingress Nginx, as it did in so many other ways, because it's the default standard, set the expected behavior for people is that if you have things that ingresses that match exactly, they'll be load balanced between them. But it actually was technically undefined by the spec. So one of the things we're trying to do is to make sure that we don't have big behavior chunks like that are not defined by the spec, that people end up just picking something. So
is it possible that one HTTP route have several gateway it match to?
Yes, definitely. So that's why you can see this parent refs is a list. It's a standard YAML list. So you definitely can have the same HTTP route attached to multiple gateways. And in fact, that's one of the ways that we anticipate people to use this, is to make it so that if you, say, are trying out a new gateway implementation, or you're migrating to a new gateway implementation, the people who own the HTTP routes can do this by just adding in, like they can just go like this. Once you save that and apply it to the cluster, then this HTTP route will be exposed via both gateways. And then when you're ready to migrate across, you remove the example gateway, and boom, you're only exposed using the shiny new one. And so that puts the purpose of this is to put this stuff back into the hands of the application developer. So as an application developer, you can have like multiple gateways available in your cluster, and it's up to you which one you pick to expose your route on. You can expose it on multiple.
Okay, yeah, that makes sense.
Okay, so let me close out a couple of these windows so it's not to be too confusing. So another thing that we probably should address that is kind of technically present in Ingress, but it's a bit tricky to do, is traffic splitting. So this is like this is weighted backends essentially. So in a HTTP route, you have your rules that sets the things that you match. If you look in some of these other, in this basic one, your rules lets you have matches, and then it has backend refs. And yeah, note that this backend ref is a list as well. And so if we go into this simple traffic split, this one is a HTTP route that matches any traffic that's sent to it. There's no host name, there's no path match. But it says that for any traffic that ends up at this HTTP route, you've got two backends, foo v1 and foo v2, and that 90% of the traffic should go to foo v1 and 10% should go to foo v2. So this lets you do canary deployments, blue-green rollouts, all the stuff that requires like a weighted traffic split.
So maybe it's I kind of like have a feeling that this gateway plus HTTP route really looks like a proxy, or it is actually it is a proxy.
So most gateway implementations use a proxy. Yes, they don't. So I'm being a little vague there because they don't have to. But if you think of a gateway as being a proxy, then usually you're probably pretty close to correct.
Okay, because it looks like this kind of like Gateway API supports lots of functions that are existing in the proxy.
Yes, absolutely. Yep. Yeah. So yeah, weighted load balancing, and filtering and default matches and TLS, and you can do more advanced traffic splitting like this. So this one is an example of where you've got you're matching for foo.example.com. You've got two rules. So if there's the default rule is that you send traffic to foo v1, but if you have a traffic header set to test, then send the traffic to foo v2. So this means that as a developer, you can have your foo v2 thing running. You can use the production infrastructure for your testing, and it's up to you to then set a header in your requests. And if you do, then you'll end up at the new version rather than the old version. So this is another way that you can do some, sort of canary / sort of dark rollout kind of patterns where you can have the thing running in production and only have it used by a certain set of people who know that to put a specific header on their requests.
So if I have like multiple rows here, like the rows here is a list, right? So how does the gateway the ingress controller or the gateway controller knows that which one has like a higher priority?
So they need to be distinct. The rules that you have here need to be distinct. They need to match a different set of things. So right. So in this case, you can see that this one doesn't have any match criteria. So it's kind of the default criteria. And then the general rule here is that more specific matches should beat less specific ones. So it doesn't matter if you've got this one before, like after this second one with the header match, after the one or before. These are not ordered. These are done by like the more specific the match is, the higher up in the list. If you think of it as being like that, it will match, and so that's defined as part of the spec.
So that's the application's developer's responsibility to make sure that there's no traffic that will match two rows here.
Yes, and so yeah, exactly. What will happen is if they are there, the implementation is expected to reject the route and say, hey, I can't configure that. There's a conflict.
Yeah, right.
So I think we've hit a lot of the sort of basic capabilities of HTTP routes. I think one of the things that's important to understand about the gateway, about how the gateway stuff works, is that when HTTP routes attach to the gateway, that we've covered already that it has like a parent refs thing. And so you say, I want to attach to this gateway. One thing that is really important to remember is that gateway owners, the cluster operator, they have the opportunity to say only some people can attach to my gateway. And so in this case, we've got a gateway where it says, listen on port 80 to HTTP, but only HTTP routes from namespaces that have the expose apps label set to true are allowed to attach. So if if Shinji, you have a namespace that has the expose apps labeled true, you can create a HTTP route to expose your app and attach it to this gateway, and the implementation will look at that and say, okay, your namespace has a label that says that, has a label that matches, so your HTTP route will successfully attach. If I have a namespace that doesn't have that, and I try to attach to this gateway, my HTTP route will be rejected and it will not attach. So the purpose here is to make it so that the people who own the gateway, like the sort of use cases that we're thinking about here are, I'm a cluster operator, I have a gateway that is for like, ultra secret services only, and only a very limited set of services should be exposed by this gateway. And so I want to limit the people who can actually attach their routes to this gateway.
Yeah, and I also noticed that the kind is also a list, and
Yes.
now it's like HTTPRoute. So is there like any other kinds that may be also valid here?
What a great segue. Thank you. So yes. So there are other. I mean, I've talked a lot about HTTPRoute. HTTPRoute is currently the resource that we probably put the most effort in development wise. But if we go back to the main website, that's this one. If we go back here, there's a bunch of other routes that you can use. And so there are also TCPRoute, TLSRoute, and UDPRoute in the core spec. And we actually have a proposal that has been accepted to have a gRPC route as well. And so each of these route types is intended to meet a different need. HTTPRoute is obviously for exposing apps via HTTP, and it's explicitly designed to be a thing where the gateway is a proxy, and the gateway will terminate TLS or do it in the clear, and the gateway has access to all of the HTTP information, right? So, the gateway reads the whole HTTP stream, has access to the headers, has access to the query parameters, all that sort of stuff. TLS route is intended to be used on a gateway where you want to take the TLS connection, and instead of stopping it at the gateway, you take the TLS connection and just pass it all the way down to the service. And so then the Kubernetes service needs to handle its own TLS. So it needs to have a certificate and a key pair, and it needs to be able to serve TLS itself. But the reason you do that is that sometimes you don't want the proxy to intercept that stuff. Sometimes you want the protocol is specific, or you're not doing HTTP. So TLS route lets you do non-HTTP stuff that is secured with TLS. The thing that's really important with the TLS route is that the TLS route allows you to only to route on the host name. When you're doing a let's TCPRoute, just seeing if we've got a good example here. So when you're doing a pass through of your gateway, you have a TLS route, and so what that means is that you pick up the gateway doesn't terminate the TLS, it looks at it, and a TLS connection has has a field called a server name indicator, the SNI. That's the host name that the TLS request is bound for, and so you can have a single gateway serve lots and lots of TLS routes, as long as every TLS route has a unique host name. So you might have, service a.foo.com, and I'll have service b.foo.com. We can share those on the same port, because when the TLS connection is initiated, part of the TLS handshake is the SNI, and even without terminating the TLS, the proxy can pick up the TLS and know that the ones for service a.foo.com go to Sinchi's namespace, and the ones for service b.foo.com go to Nick's namespace, or Nick's HTTP routes. Sorry, that was a very whirlwind tour through TLS and SNI. Does that make sense though?
Yeah. And also that so this table means that only the TLS routes support the path through, and the other two only support the terminate. Does it?
Yes. So the TCP route is intended that if you're using TLS with a TCP route only lets you match on source and destination address and port. So there's only 6 pieces of information that you can match when you're doing a TCP forward. So if you're proxying TCP, the way generally the proxy works is you have to stop the TCP connection and then start a new one. There are a few other things that you can do there. You can forward TCP streams on, but if you're doing a TLS termination, you have to stop the stream there, do the TLS handshake out to the client, and then start a new TCP stream. So I guess I'm getting a little too in depth there, but the idea here is that because we have the different types of route available. So we've got TCPRoute, TLS route, and UDP route. Those are intended to just give the API space to describe those things. So I'm kind of hopeful that in some period of time, a year or two, that clusters that you run on a cloud provider, instead of having to use a service of type load balancer to expose your layer 4 service, you'll actually be able to have a gateway that says that you can attach TCP routes to, that will say, hey, please expose my layer 4 service here. And that's the same thing as a service type load balancer works today. Like if you create a service type load balancer, it sets up a layer 4 forwarding path for TCP service. It might be proxied or load balanced somewhere upstream. You don't really care. All you know is that traffic will arrive at your pods that are part of that service. And we want there to be a way that you can do that with the Gateway API as well.
So this different kinds of routes make this Gateway API both L4 and L7.
Exactly. Yes.
That's really powerful. It looks like the Gateway API can do what the Ingress and the LV service can do. So is that possible? Is that possible that maybe sometime in the future the Ingress and LV service will be deprecated?
So no, because those things are V1 APIs now. The Kubernetes Api Guarantee is that those things will be around like forever. Removing I don't think Kubernetes has ever removed a V1 API. I don't really see any reason why we would. So there will be still support for those things forever, I would imagine, so that we don't have to worry about people still wanting to use them. The idea here is that we make the Gateway API more attractive by giving you greater control. When you're talking about service type load balancer, there's a lot of magic in that today, and if you want to use the same service type load balancer on AWS or GKE or Azure, there's a whole series of annotations you've got to put on your service that sort of direct the cloud load balancer to do certain things, or Entree as well, I would imagine. And so the idea here is to make it so that you don't need to use annotations on a load balancer service to do that. You can have a gateway that explicitly configures stuff, and that you explicitly say, please expose this port and please route those ports to here and stuff like that, so that to take the config out and stop it being so magic and make it more explicit. The downside of that, of course, is that because it's less magic, it's more wordy, it's more verbose. There's more stuff you've got to do to make it set up. But the thing that's going to let people do is that if you want to just do basic stuff like you're doing today, then the service type load balancer will be there, and it'll be able to just, I just want to expose my service. I don't want to worry about how it works. You can still create one. You'll always be able to do that. But when you run into things like, I'm running in AWS and I don't want application load balancer, I want a network load balancer, right? Like then you can create a gateway that describes how your network load balancer works more closely. I want network load balancer and I want to do, and I want to be able to set my cluster networking to cluster instead of, my external traffic policy is cluster or local, right? Like we should be able to have it so that the gateway lets you control that stuff without and in a more explicit and easy to understand way than the service resource.
Yeah, that makes sense.
So yeah, I think we're running close to time, but so I don't want to dive too deep into this stuff, but I did want to just make sure I hit that the Gateway API is 100% not just layer 7. We spend a lot of time doing layer 7 because that's what like most use cases in Kubernetes are, exposing HTTP things. So it's really easy to get people to check that. There is definitely a lot of interest in people doing TCPRoute, TLS route, and UDP route. I think UDP route is absolutely the hardest to get right, because UDP is much harder to proxy because it's a connectionless protocol. Yeah, and so I think TLS route is, so I would rate in terms of the 4 things we have in there at the moment in terms of support by implementations. HTTPRoute is the most supported, followed by TLS route, probably followed by TCPRoute, and then last is UDP-route. But the idea here is to tell you all that we have these things in there for a reason. The API is intended to cover all of those layers. And in fact, we've actually talked briefly a couple times about having even be able to gateways be able to describe like other layers, like to have like a VPN route or a GRE route that would describe the process, to use the gateway to describe a router instead of a load balancer, right? And so to use a gateway, you can use the construct we have already for gateway to describe something like a router that builds a VPN tunnel between 2 clusters. And so that sort of strays into the sort of tailscale kind of territory, but like that's the we've tried to make sure that the concepts we have for gateway don't stop you from doing that, right? And so we have the option of exploring that space later. Would we do that anytime soon? No, hell no. There's too much work already in what we've got. We've got so much work left to do. As always, we're definitely looking for, as like every open source project, always looking for more people to help with the Gateway API. I think in terms of news about the Gateway API, the biggest news is, hey, we just recently released a version that contains the V1 Beta 1 versions for GatewayClass, and HTTPRoute. We're building out a series of conformance tests that can test implementations to ensure that they're conformant to the spec. We think that this is like absolutely critical for making sure that the spec is actually viable, that you can move your config from one implementation to another. And lastly, yesterday, actually, there's a new sort of sub project. The Gateway API is a sub project of SIG networking. We now have our own sub project, which is the Gamma initiative, which is about taking Gateway API resources and using them to describe service mesh things. So there's a lot of activity starting up there as well. That is extremely early days. We literally have had one meeting about it. And so, we're in a lot of sort of very early days stuff there. But the idea here is that everybody wants to spin around using this API to describe all sorts of networking stuff, not just, the north-south path of ingress traffic is the first thing, but we also want to be able to use the API to describe east-west traffic, service mesh style traffic.
Yeah. So, is there like any other questions from our audience? So now there's like no more new questions in the comment, but feel free to drop any questions you have to the chat so we can answer that in real time. And like anything else that anyone want to discuss? Okay.
We're a little early, but I think I kind of if I started to discuss too much more about details of anything, like it's going to take a lot more than the time we have available. So I kind of want to keep this as like an introduction for folks. The other things that are relevant, actually, I will just share my screen one more time so that I can. Sorry, sure. I keep flipping backwards and forwards.
No problem.
I should point out the contributing page, the community page on the website that has like where to go. We have so on the Kubernetes Slack, we have hashtag SIG Network Gateway API is the channel to come to talk about. We have 2 meetings a week now. The main Gateway API meeting and the Gamma initiative meeting. So those are available on the SIG Network meeting calendar. You can see this is a page about the Gamma initiative. It stands for the Gateway API for Mesh Management and Administration. It's also because it sounds like a cool name that could be in a Marvel movie or something. So I just wanted to make sure that I'd sort of pointed out that this is the place to go to sort of find out more about how to contribute if you are interested in contributing. Like I said, we have far more work than the people who are involved can currently do. Okay, cool, great question.
There's a comment from the Alexandra.
Yep. Yeah. So you can see that Alexandra was saying about
It's actually not a question. One thing that I miss a lot is there's a possibility of expose a PostgreSQL service, for example, and restrict the IPs to access. It's impossible to do with a no port.
Yeah. So
you could do the same in the gateway API gateway.
We definitely have some requests in the Gateway API for this functionality. Lots of people want something like this. Doing it in the right, one of the things that we run to a lot with this API is that we want to make sure that we do it in a way that's extensible and like able to be supported by lots of implementations. And so sometimes it can take us a little while to define the constructs in such a way that they make sense, they fit in the API, and that everyone agrees. So we definitely have some requests for this. It is definitely a feature that we want, but it is not done yet. So I 100% agree. It is really important that that there should be allow lists and block list functionality available in the API somewhere. But we've had a couple of people have stabs at it, and it hasn't felt like the right thing. So, we really want to be careful that when we put this in, it's forever. And so we've got to make sure we get it right. So yeah, it's definitely an issue that we have talked about. Let me just see if I can find, there is an issue that I want to, just let me see if I can pull up the issue and put it in the chat. There we are. So one of the other things that's relevant is that we do is that in the Gateway API we do similar to KEPs, we do gateway enhancement proposals. So this is a GEP. This is an issue that describes a GEP 1141 for adding allow list and block list functionality to the Gateway API. So you can see there's a few people. A few people there. This is for HTTPRoute, but we've definitely got definitely had requests to have a more general sort of allow list and block list functionality as well. And so to read a bit more about making changes, if you have a look at contributing, enhancement tracking and backlog. So this is the process for how to start a new GEP.
Yeah, and if you like have if customer kind of run out of time, so if you have any further questions, feel free to reach out to Nick in the upstream Kubernetes Slack channel, and we would like to have any feedbacks or questions from you guys.
Yes, definitely.
Yeah. So thanks everyone for watching, and thanks Nick for telling us so much about the Gateway API. And I really have a better understanding of it. Basically, I don't know. I know nothing about it before the show.
I think very few people know anything about it as yet, so I wouldn't feel too bad anybody not knowing about it.
Yeah. So thanks so much for sharing this kind of knowledge with us, and hope everyone enjoyed this show. And see you next Wednesday.
See you all later. Bye.
Bye.